Welcome friends, thanks for watching our tutorials. Today we are going to discuss about two important concepts as related to data science. One is NumPy, which is used for arrays. The next one is pandas. Both are key areas to step into the data science world. Also we'll touch on the lineage module for linear algebra and the matplotlib, the plotting library basically in Python. More about the statistics. Plotlib is for statistics. So the first or the key step in the NumPy is creating an array. Arrays can be created multiple ways. Either you can create it by hand, load it from a file, to CSV file or the text file, or you can pass the array to the NP or the NumPy to create an array. So let's take a look at the basic methodology. So the syntax is np.array, and basically any array is homogeneous. That means all the elements within the array should be of the same data type. Okay. So, but if you have a complex object, how do you do it? Where you have multiple different data types, how do you do it? That's where you pass the tuples, which helps to make sure you can pass even though the element itself, as you take a look at the array as a whole, it's homogeneous, but you are able to pass different data types within the tuple. So that's how you can create the NumPy array with heterogeneous data. So one of the key features or the key thing which you need to remember is D type or the data type. So the data type, there are a couple of key things we need to remember. Data type will define what each element represents. So here, what does 393 represent? So we are defining it in the top. We are passing the D type dt to the array. So dt here 393 means density, and it is 32 integer. What does milk represent here? It's a name with a string type of 20 characters. Okay. So this declaration of D type is pretty important, how you define it. If you don't define it properly, the values can be changed, and the array which you want might not be the array which you get as an output. So that's the significance of D type. Also, there is one more significance of D type. So if you want to pull only let's say 393 out of this one, you can say x of 1, which means it pulls the 393 and milk. But the simplest way to pull it out is x of 1 in n density followed by density, it will give the 393. It's much easier that way. We will see with an example, but just wanted to explain how or the importance of D type. Okay, let's go to the example within the Jupyter notebook. So the same example I'm showing here. I created an array, two-dimensional array. So one dimension here, the second dimension here. Okay. So if you see, this itself is a list. This itself is a list. Again, you have to do one more square braces. That's pretty important to make it as an array. So this itself is a list, this itself is a list. Again, you have to pass one more square braces on top of it to pass it as an array. So this is a two-dimensional array, and here you are saying D type is equal to dt. So you are, as I explained, this is density, this is name. That's all good. Here it's declared as int 32, here it says s20. But let's take another example here. So the gt1, you created a new data type and pass it to this one. So let's see how y was printed. So 390. So why you are printing it here after the first star marks. So you can see 137 instead of 393. Why, you might ask that question. You are passing the density to be unsigned integer 8. It goes only until 256. After that, any value you pass, again it starts the increment. So if you don't pass the d-type in a proper way, you will be losing, or you'll be misrepresenting the array you're trying to represent. So that's pretty important to ensure you pass the right d-type. So also, if you want to know, let's say somebody gives an array, you wanted to understand what are the data types in it, you can just say print x.dtype, which gives you the density and the name with their data types as well. So d-type is pretty important. We will see in the next example the slicing, how d-type is much more important. So let's go back to the PowerPoint and let's discuss about slicing. So in slicing, there is a basic slicing, there is a complex slicing as well, where you can select the data based on a condition. That's a complex slicing. What does slicing mean? In a database world, whenever you're querying the data, even though you might have table of 100 columns, you don't want table of 100 columns every time. You want only the first probably selective 5 columns. The same thing ability you have to have in arrays. That's nothing but the slicing. So here, as you can see, the syntax, basic slicing, 0 colon, 1 colon, what does that all mean? So let's go to the next slide, then we'll come back here. I explained slicing in a better way there. Then we'll come back here. So here you have this example, an array, a 2-dimensional array. So I am saying slicing every time will be done by start, stop, step with colons in between. So if I say x 0 comma 0 colon 1 colon 0 colon 1 colon, what does that mean? So it's asking to start at the 0th element in the row from the row standpoint. So this is a one row, this is a second row. So you start on the first row and end at the second row. This is a 0th index representation, right? 0 means first row. So you want the first row and end at the second row. So you get everything. Again here, what I'm saying is, here I'm saying again in column wise, I start from 0 and end at first column. Okay, so which means I want within this first row I want first 2 columns, and in the second row also you want first 2 columns. So that's the reason this is how the resultant array will be. So the last one step, if you leave it, it will be defaulted to 1. Let's take the next example. Here we are saying start with 1. So first row, second row, you want from, let's make this 0, then it will be correct. So I want everything in the rows standpoint. 1, 2, 3, 2, 3, 4. But here in column wise, you want from starting from the second row onwards. So obviously first column will be gone. So 2, 3, 3, 4. This is the output. Okay. This is how the slicing is done. So this is what I am trying to explain. So let's talk about the indexing. So here in indexing, x of 0, 1, 0, 1, which means you are trying to get 0, 0 element, 0, 1 element, 1, 0 element, 1, 1 element. That's how the indexing has to be read. And let's come to, this is basic slicing and indexing. Now coming to the looping standpoint. You have couple of ways to do looping. Either you can iterate through each element and then pick the right elements which you are looking for, or NumPy has given an option where when you can say np.where and you can say x of density. This is where the data type helps. X of density is greater than 0. If it is 0, add +1, or otherwise -1. So this is much easier if you think about it. I don't need to iterate through all the values and then find out. It's much easier to do this way rather than using the list comprehension or the for loop. So let's go back to the Jupyter notebook, then we can see this example. So I explained the same thing, basic slicing we discussed about. As you can see from here, 393, 337, 256. This is the two-dimensional array here. What I'm doing is I am saying give me all the rows, but from the column standpoint, start from the second column onwards. So that's the reason you only see 337, 256, 385, 300, but not this one. Okay, that's the next is indexing. As I intimated, the indexing is all about this 0 row 0 column, which is 393 B milk, then 1,1, which is 385 water. That's how the indexing has to be read. 0, 0, 1, 1. If I have said the other way, I mean, if I did the cross join not that way, but you have to use the first 0. This 0, 0 is this element, then 1, 1 is this element. That's the output indexing. Okay, now let's come into the selective export of the data based on a condition. Here there is selective columns we are exporting out, but not based on a condition. But now I decided to have certain values only based on a condition. That's where you have to do iteration. So you can do iteration in multiple ways. I can iterate through an array, okay, using a for loop through each element, right? So since each element is again a tuple, I have to again do one more for loop. Then I have to check each element, what is the condition, then I have to print out whatever I need. Okay, that's one way. It's a much complicated way with arrays. Probably it works with lists and all that stuff, but with arrays there is a much neater way. Okay, there is one more way. Instead of for loop, I can go for list comprehension. If you are not aware what list comprehension is, please go through Google search. You should be able to find it out. All you are doing is, I am doing a for here. Okay, I'm doing when I'm doing a for, I can, in general, this is one for, and within that I am trying to do this. So there are two fors here. Okay, the same two fors are listed this way. For xr in x name, for xr in x of name, nothing but this one. For yr in y, this one. Okay, for values in zip yr xr, whatever you get from here you're putting here, then you're getting the values. So the same thing is represented here in a list comprehension way, basically. I mean, instead of putting in multiple lines, you put in one line. That's nothing but the list comprehension. So there is a much cleaner way which Python gives, which is np.where. All you need to do is, if np.where x of data type is very helpful here. If x of data type is greater than 0, here in this array, if it's greater than 0, I'm asking to add 1, if not reduce 1. That's all I'm doing. I don't need to loop through the array. I just need to say np.where x of the data type is greater than 0, then do this, otherwise do this. See, alternate to looping, it's much cleaner and it comes out very quickly. So everything got decremented here, or sorry, I should have said incremented. If it's greater than 0, incremented. So as you can see, the array is this one, 393, 337, 256. It got incremented here, 394, 338, 257, so on. So this is about the slicing, with basic slicing, indexing, and also the selective way of slicing. You wanted to do slicing based on a condition, something like that. So this is about slicing, which we discussed. Let's go into the lineage module, linear algebra. So here, linear algebra. So I was taking a real life example here, and trying to show you how we can solve without using Python lineage, and then we can take Python lineage and see how easily it can be solved. Okay. So I'm saying there are 3 cars that I rented out for span of 3 months. Okay. 1 trip happened on the first car, 2 trips happened on the second car, 3 trips on the third car, produced me $1,000. Okay. Similarly, I have one more data point, which is 2 trips on first car, 1 trip on second car, 2 trips on third car, produced $1,200. Again, the third variation as well. I have the third data point as well. Okay. So I'm not sure how much first car has really produced me. All I know was these data points. How do I find each car has produced? So I come up with an equation. 1, the variable how much X car has produced. 2, how much Y car has produced, Y. 3 into how much the third car has produced is equal to 1000. So I come up with 3 equations here. Without using Python, how do you do it in general in algebra class? You can use echelon methodology, reducing the rows, right, into a echelon format. So I'm doing the same at echelon methodology here. So what you need to do with echelon methodology is you have to make sure under the diagonal it's 0. So that way you can then use so obviously then you can get the z value easily because these two are zeros. Then you can use the z value to substitute here. Obviously this is zeros, you substitute the z value here, you get the y. Here all 3 values are there, but you already know y and z. You can do the substitution for y and z, you get the x value. So that's how. So in order to do the echelon methodology, the key important step is you have to don't think of every time subtracting. Sometimes you have to add it to make it even. So what I'm doing is I'm adding these 2 steps, and in row 3, sorry, row 3 plus row 1 in row 3, and then divide row 3 by 4. So it all became 1, and 2400 by 4 is 600. So this is how we arrived. So the next step is you have to do series of steps again, what I have done. So once you do this, you come to this one, then you got these values. Z is equal to 800, Y is equal to minus 800, X is equal to 600. How you got that? As you see, once you reduce it to echelon methodology, 2 by 3 of Z is equal to 400. Obviously, Z becomes 800. So once you have Z, so you come here. So here it's 1y plus 4 by 3 Z is equal to 0. Already you know Z value. So for 1y plus 4 by 3 into 800 is equal to 0. So you know the y value, which is minus 800. Now again you know those 2 values. Now 1x plus 2y plus 3z is equal to 1000. You know y, z and y already, so you get the x value 600. So this is how you can do it. Let's go into the Python way. So I constructed the whole thing here into 2 different arrays. 1, 2, 3, 2, 1, 2, 3, 2, 1. This is one array, and B is another array. So if you see here, this is one array A. This is nothing but from 1 to 3 to 1 2 3 to 1 is one array. This is one array. So a variable is equal to b. So all I need to do is x. So I need to know the value x. You get the value x by x is equal to b into a inverse. If I shift this one here, b into a inverse. So this is what we are doing here. X is equal to np.nalg.solve a comma b. Then you get the print x. So whatever you have done in 2 pages to get these values can be obtained in a very quick way, as you can see. So thanks for watching Noob tutorials. We have covered arrays, slicing, and the complex slicing as well, and then the linear algebra. In the next session we'll be covering brief introduction of the statistics and the bar graphs and the histograms, and then going to the pandas. Thanks again for watching Noob tutorials. Thanks for watching Noob tutorials.